excited to start AP Physics with you guys, and I hope you're excited to be in AP Physics next year. I wanted to do a little bit of review with you before we start the school year. And the first bit of review is a really basic vector review. We'll go more into depth as the year progresses and as we need more, but this will take us about, I would say about 90% of the way through vectors, which is fantastic. If you want more information also after we finish the video, you can of course watch the video again, and you can always check pages 8 and 9 in your textbook for more information. Alright, so first it's a math test. Don't panic, it's only a test. Oh, I'm going to have to erase this every time. Okay, so trig review. So we have a right triangle, we have the hypotenuse, adjacent. Oh, well, we don't know which one's adjacent or opposite until we mark an angle. And once we have an angle, the sides that is touching the angle is the adjacent, and the side that is not touching the angle is the opposite side. So we have the adjacent, opposite, and hypotenuse. If I draw the same triangle but just make it larger, they're called similar triangles. And we have the same angle here, the 26 degrees. The purple side's still the hypotenuse. The side that's touching the 26 is still the adjacent, and the side that's opposite is still the opposite. If we say that this large side, this large A, is twice the size of this small a, then that means that every side is also increased by 2, by a factor of 2. Similarly, if we were to take ratios, a over h, and we do the small a over small h, the 2's would cancel out as well. So the ratios are always equal. And this ratio for us has a special meaning. We could use trig functions, so adjacent over hypotenuse is always equal to the cosine of the angle. And in degree mode, this would be about 0.9. Opposite over hypotenuse and opposite over adjacent. Some of you guys know SOHCAHTOA. Which is great. I learned it as some old horse caught another horse taking oats away, which was really helpful for me because I am a horrible speller, so spelling SOHCAHTOA was a little bit scary when I first learned it. So whichever way works for you, that's great. Let's erase that and go on. So problem number 1. We have an angle and we have a hypotenuse. I want you to go ahead and solve for the adjacent and opposite. Pause the video and then come back when you're done. Okay, I hope you're done. So here we go. Here's the, so we want to solve for the adjacent and the hypotenuse. We could do, okay, so if we want to solve for the adjacent, we know we have the adjacent and the hypotenuse, so that would be cosine. So we would write cosine 26 degrees is equal to adjacent over hypotenuse. And we multiply both sides by the hypotenuse, so we have the hypotenuse times cosine 26 degrees is equal to the adjacent. So always is the hypotenuse times the cosine of the angle is always equal to the adjacent. And it's just easier because most of the time in physics we will have the hypotenuse and we will be looking for the components, what they call the components of this hypotenuse. So we could go ahead and say it'd be 65 cosine 26 degrees. And you can remember that the cosine goes with the adjacent because the adjacent is cozy up to the angle right there. And the opposite will have sine. Okay. So you solve for that in calculator and get about those. And I'm sure all of you got the right answers. Okay, so let's try this one. We have the adjacent and the opposite, and I want you to find the hypotenuse and the angle. So take a moment, pause it, and try this problem. Okay, we're back. I hope you guys all solved it. All right, so since we have the opposite and adjacent, we could go ahead and use tangent. Oops, and before that, sorry, I forgot what came up first. We could use Pythagorean theorem to solve for the hypotenuse. So a squared plus b squared equals c squared. And so 4 squared plus 3 squared equals 25, so the hypotenuse is 5. And then, since we have the opposite and the adjacent, we could use tangent. Now, to get tangent all by itself, we'll have to use the inverse tangent. So theta, we bring theta out to the other side, and we put whatever's on the other side back in. It just switches the role of the output and the input. And you get, I believe, about 37 degrees. Okay. So there we go. Alright, so this should be all old review and easy for you guys. So I hope that is. Okay, erase. There we go. Okay, vectors. So vectors are quantities that have both magnitude and direction. So magnitude just means how big. So I often get questions about, well, it wants me to find magnitude, but I don't know the units. You always have to continue reading. Anything that's a vector has magnitude, has how big it is, and a direction. So some examples of this may be displacement, velocity, or force. The way that we represent vectors is with an arrow. So the larger the magnitude, the bigger the arrow, and the direction is which way the arrow is pointing. In comparison, if something's not a vector, it's going to be a scalar. And scalar quantities are just magnitude only. So can you guys think of anything that you would want to describe with just a number and not a direction? Mass would be a scalar, and also temperature. When we say it's 74 degrees outside, we don't say 74 degrees west. That would mean that would have a completely different meaning. So, oops, let me erase my pen marks. There we go. Okay, so all of these represent equivalent vectors. Vectors, they all have the same length, and they all are pointing in the same direction, but vectors you can move around in space. Okay. So if we have vector A here, to get vector 2A, we just double the length. To get vector negative A, we use the opposite direction. How do you think vector 1/2 A would look like? Approximately like that. And we use the little symbol up here to denote that it's a vector. There's two ways you'll see me write vectors. You'll see me write it with a little arrow on top, or kind of the box, or make it pretending it's bold. In your book, sometimes they just bold the letters to show that it's a vector. And this is how I would write a bold vector with just my pencil and pen. Let's make it A, B, C, D, so on and so forth. Okay. Erase that. Okay, you're supposed to erase when I shake it. There we go. Okay. So, there are lots and lots of ways that we're going to use vectors. The first and probably the simplest way is for displacement. So let's say we start in the physics room here in room 230, and we go to the gym. And once we're at the gym, we do what we need to do, and then we're going to go to the dining hall. And we want to find our total displacement. Now our total displacement doesn't matter from where we start to where we went exactly. It just matters from start to finish. So notice a couple things. I want you to notice that we started here in room 230. We went up here. So this has an arrow at the end. So, and then we started here, we went here. So we added these two red vectors, head to tail. And then at the very end, we went from where we start to where we finished. So at the very end, the two heads are touching. Okay. So, adding two vectors, vector A and vector B, we could do this graphically, and we'll get a lot of practice with this in class. So we always add vectors head to tail, no matter what. And so the sum, we'll call it C, or this blue vector, goes from where we started, so the beginning of A, to where we ended, the end of B. Okay. So here's the other one. Okay, so this just shows us A plus B, so head to tail, equals C. Goes from where you start to where you ended. Okay, so that is our review for vectors. The next video will have a couple problems for us to play with and try together. Okay, have fun!